myself, but if you guys have any questions, we'll address it in the chat.
Thank you, Owen. All right. Hi, everyone. How's it going? Like I promised, version control might be one of the most important tools you guys will use as a developer. It will save you hours of work in the future. So I highly recommend you get really familiar with any kind of version control system. We're going to focus specifically on Git and GitHub because that's just what I've been using the entire time I've been developing. But if you guys are familiar with something else and would like to share it with everyone, feel free to shoot one of us a message. We can set up something where you can talk to everyone. Okay. First off, what exactly is version control? So if you guys can take a look at my screen, this is our starter guide, and it kind of gives you the overview about GitHub specifically. But Ansh had a pretty good, and I guess not pretty good, but he had an analogy before that said version control is like the Google Docs of code sharing, which is correct in the aspect that you can collaborate with people very effectively. You can share stuff very easily with other people, and you can all make changes at the same time without worrying about anyone breaking something. It's just not a very good analogy because I don't want to compliment Ansh. Anyway, so the difference between Git and GitHub. So I'm going to get right into the what we're going to talk about right now. The difference between Git, GitHub, and how you guys are going to work through it. So I'll give a little demo later on about how you go about the entire process, but just overall, Git is what the technology is actually called. It's a version control system developed by Linus Torvalds. You can see his name right here, who created Linux. So he's the guy who created most of modern computer architecture. GitHub is actually a company headquartered in San Francisco that really focuses on allowing you to store your work remotely so that you can access it from anywhere in the globe as long as you have a secure internet connection. So the idea of the reason why you would use GitHub is because I'm sure most of you are not actually in the same place as your team. So if you guys all collaborate together on this, you can ensure that everyone can write code at the same time. You can share code with the rest of your team, and you don't need to worry about someone making conflicting changes or some people breaking something that someone else already did. That's kind of the overview. I'm sure you guys can already figure out why this is going to be really useful for you because you guys are supposed to be writing code over the next 8 weeks. So this should be a pretty useful workshop. And I know we already had a request for me to go over .git ignore files. So I'll do that later. If there's something else you're confused about, something else you want me to go over specifically, feel free to either just drop it in the chat, or if you want to save it for the very end, then you can unmute yourself and talk it through. Yes, Sridhar, Git and GitHub are two different things. It's a pretty confusing thing because they both have Git in it, but Git is the technology, GitHub is a company. They're not owned. GitHub doesn't own Git at all. Git is actually open source, but GitHub is just a way for you to save all your Git files onto a remote server. All right, so let's hop right into it. I talked a little bit about this yesterday in the Getting Started workshop, but I think the best way to learn anything is actually to hop right in and start doing an example. So let's go ahead and do this. I'm gonna do everything on the terminal because that's just what I'm more comfortable with. And I'll also show you guys the GitHub desktop app, and maybe that might be more intuitive for some of you guys. Either way, you can do the same thing that you would do with both tools. So let's just get right into it. So this is github.com. This is where you'd go if you've never used GitHub at all. I guess I can log out. So you would this is what the page would look like if you've never logged in. You'd go ahead, sign up if you haven't signed up already. If you have an account, just go ahead and log in. That's all pretty straightforward. Now, when you join, you won't see what a repository is basically like a project. So over here, the Ultimate Hackathon starting guide that we have going on is a project that we've built. So I can just go ahead and show you. You click on the project and all your code will show up over here. So all of this are your code, your different folders. And this is a description that you type up about your project. So what exactly you're going to be doing. Yeah, I will talk about the GitHub education pack. I'll save that for the end though, because that's not part of the workflow. All right, so let's go straight back into the process. You're going to be creating a project. So this is something that your team is going to be working on together at the same time. For GitHub, projects are stored in something called a repository, or repo for short. I'm just going to call it a repo because it's shorter. And to do that, you're going to create a new repository by clicking on the new repository button. Let's create a new repository. Let's call it Summer Hacks. Oh, by the way, if you guys want, you can go ahead and follow along. But we're going to record this entire workshop and post it to our YouTube channel later. So don't worry if you miss something or want to go over something again. You'll have access to everything later. And let's add an optional demonstration, teaching Git GitHub. All right, perfect. I'll keep it public. A README is what I showed you guys earlier. It's a quick description of what's actually going to be happening in that project. And yes, I will go over Git Ignore in a little bit, but you guys don't, most of the rest of the stuff is optional. Let's go ahead and create it. So we have this, now this is our project. Currently, I'm the only one actually working on this project because I just made it. No one else is actually contributing, but I can go ahead and add my team. Excuse me, manage access. So you want to have your entire team on this, on the Git repo so that you can all start adding code, editing each other's code, leaving comments on what each other, like your other team members do and so forth. So I'm going to go ahead and just send out a couple invites so you guys see the, I forgot Ansh. There we go. Okay, so I'm going to add Ansh as one of my collaborators, GameBot2. So if he wants now on his account, when he logs in with his username, he'll be able to see my invite and he can join this repository. He's a collaborator, so he can also start adding code. So let's go back. Now let's actually add some code to this so you guys can see what's going on. First off, I want to create a local copy of this repository on my computer because I'm not going to start writing code in the browser. So I'm going to go. You want to clone it. What cloning means is that you're creating an exact copy of what is on the remote server, the remote GitHub server on your local computer. So think of it as just copy pasting from the remote server to your local server. So I'm going to go back to my terminal and I'm already in so if you look, I'm in a specific folder. This is just where I want to create my project. So git clone. And there we go. So I just cloned the, if you take a look, I have a summer hacks -demo folder, which is equivalent to the remote repository that I have on github.com. So let's go into this. All right. And I've set up a couple of skins in my terminal. So just because it's easier for me when I'm working, but it tells me that I'm on the master branch. You can also see that right here, that the only branch that I have on my project is master. The reason you guys want to know what a branch is because you're all going to be working potentially on the same piece of code at the same time. So I'm going to real quick explain what exactly a branch is and why you guys should care. First off, you have your remote repository, which you see right here. A branch is any potential change that you want to make to the code. So let's say I have a really hefty code base. Actually, let me just show you guys an example. It's definitely easier to explain. Sure. I think this. No, where's my? There we go. Okay. So I'm going to show you guys one of the projects that I've been working on. But if you look here, I have 5 different branches. Each one of these branches represents a different feature that I've been working on that I don't want to have in my final project. So let's say you're working on a really complicated computer vision machine learning project. You assign one team member the computer vision aspect, you assign one team member the machine learning aspect. They both should create their own branches, write their code, and in the end, they'd make a pull request and add it back to your master branch. I'll explain what all those terms mean. I'm just trying to give you an idea of the overall workflow, what you guys should be kind of envisioning in your head. So each one of these branches over here represents a specific feature that I've been working on, but I don't want to add to my main final product yet, which is my master branch. So let's go back to our Summer Hacks demo. All right, now let's add a file here. So let's add, what should we add? Touch demo.py. All right, so now we've added a file here. It's just demo.py. Let's edit it. Give me a second, my computer is being very slow. There we go. Oh my God. There we go, okay. Oh. So what I did just here was I opened up an IDE, Visual Studio Code. in the specific repository that I'm aiming to work in. So that's the Summer Hacks demo. So here I have my file. Any change I make here will happen obviously only on my local server. So I'm only going to be doing it on my computer here. Nothing I do right now can break the main code branch that we have on a remote repository. That's one of the benefits of Git. You can experiment, you can play around with whatever you want without risking that you might accidentally break something that you've already done that already works. So let's go ahead and, I don't know how to write Python code. All right, let's go ahead and type. I don't know if that works. Oh, no, it does not work. Ansh, how do I write Python? Okay, whatever. Anyway, doesn't matter. Nice. Okay, that works. There we go. Okay, we've written Python code because I don't know how to write Python. Now let's add this back to our remote repository. So let's do a git status. What this tells me is that we haven't added the, yes, give me a second for there. So demo.py, we've made a change in our local repository, but we haven't actually, we aren't tracing it in our entire Git system. So the way you want to, the process you want to use to add something to our remote Git repository is as follows. And again, this is all in our starting guide, so take a look. Alan made a nice contribution earlier. We want to do git add demo. So what I did just here was I added the demo.py file to the Git version control system. So now Git knows that demo.py is a file that actually exists in the server. Now if I do a git status, it says that there is a new file named demo.py. Before it said it was untracked, which means that it had no idea there was a file like that. Now we want to commit it. Committing means that we've reached a point where our code kind of works. We want to save it, basically. So we want to mark it as a checkpoint in Git, telling it that here we've reached a checkpoint. This is what it does. Let's go ahead and git commit. The -m flag is going to give me a message, so I can type in a specific message. Added print statement. Perfect. So now if I hit enter, I've made a commit saying that I've added a print statement at this specific point. Now let's push this to our remote repo. So I'll do git push. And because it's already cloned, it knows exactly where I should be pushing stuff to. And if I refresh, there we go, like magic. And it'll give you a print statement because that's the commit message that I gave over here. Shridhar asked, does the touch command work in any folder? Yeah, touch is a built-in terminal utility that works on Mac and Linux. So I don't know if it'll work with, I don't know what the Windows equivalent is, but yeah, touch basically can create any kind of file in a Mac OS or Linux terminal. So but this is just exactly what I would do if I were working on my own project. I would write code and add it, send it to Git. However, let's say my name's Ansh and I'm trying to make a specific, I'm trying to make a change that might actually conflict with something that Kush is doing. So I'll make my own branch. Oh, actually, let me show you this. So it's the only branch that I actually have right now is master, right? Because that's the default branch that's created anytime you initialize the Git repo. So let's create a new branch. Ansh working. So the -b flag over here means that it's a new branch. So this branch doesn't exist before, create a new branch. All right, now I've created a new branch and you can see what the branch is called here. Now, if I open up, go back to my terminal, you can see down here, just the way I've set it up, that it automatically switched over to Ansh working. And most IDEs will do the same thing. So if you have, let's say, Visual Studio Code open from a terminal, and you switch which branch you're working on, it will automatically open up to the different branch. So if I do checkout, I don't do a -b here because master already exists. This would switch back to master automatically, and then there we go. So now I'm writing something for Ansh. So I could do print, my name is Ansh. All right, and this is a change. So I've made a change. It might conflict. I'm gonna delete this. So it's something that's different from what that's on the main branch of that. Yeah, I will go over that. Good question. So again, let's add this back. Tell Git that we've made a change, this file exists. Now, Didi asked, what does a commit do? Do I always need to commit? A commit, like I said before, actually signifies that this is a checkpoint. I'm gonna push my code to Git. So it's basically saving it's like hitting Control S on a Word document at every time, except that every time you save it, it saves a different version of your code. So it's taking a snapshot basically and letting you push that snapshot to your remote server. So I've made a change. I want to save it again. Git commit and my name Ansh. Fantastic. I've pushed it. Now let's see what happens if I do Git push. It doesn't know what to do. The reason is because even if I refresh the remote server, it doesn't know that there's a branch named Ansh master. See, the only branch that shows up on the web portal is master. It doesn't know there's a branch named Ansh working. Excuse me. So to do that, it's as easy. It basically tells you what you need to do. Just copy paste or type that in again. What this is going to do is it's going to push the new branch that you've made, push that to GitHub, and then it's going to push all the changes that you've made, push that on that branch to GitHub as well. So here you can see, okay, it automatically pulled up that I've pushed a new branch named Ansh working. So let's say Ansh added a new feature, he made it on the branch Ansh working, he pushed it to GitHub. So now I want to merge it back into the master branch, which is the final product that I'm going to show off to all the judges at the end of this hackathon. So luckily Git, at the beginning I'd suggest just use the web portal for all of this because it makes life a lot easier. Go ahead and hit compare and pull request. And that's exactly what it says. It's going to let you compare the changes that are different between that branch and your master branch. And it's going to let you make suggestions, make modifications, and give feedback to whoever actually created that branch. So even if Ansh logged onto GitHub, accepted my invite, made his own branch, pushed, and then made a pull request, I would be able to see what changes he made. I'd be able to see what he did. I'd be able to leave feedback before we actually put his changes into the master, the final product. So here you get to see I changed one file because I only have one file, and you get to see all the changes that I've made. So minus means that I deleted this line, plus means I added this line, which is exactly what I did. And so I'm going to make this this pull request, making changing print statement. All right, so Ansh would do this. He'd make a pull request. And then if I just logged on back to my GitHub, I'd be able to see a pull request. I'd open it up and I'd see what the changes are. I'd see what Ansh wants to change. Okay, that all looks good to me. Looks good. I would submit, and then I would merge this pull request. So merging basically means that all the changes that Ansh made on his Ansh working branch are now pulled into my main branch, so pulled into master. And now, like I just said, if we go back, we'll open up master. It's going to say exactly what Ansh made, all the changes that Ansh made. So, so that's the overall workflow about how you would use you'd use Git, why you'd use different branches, how you would have different people collaborate on the same project at the same time. Okay, so two things that I need to talk about. One, the GitHub education pack. So this is something that GitHub's made available to all students for free, regardless of your major, your where you are in the world, whatever, as long as you have a working .edu account, a school email. So basically, I honestly just look up GitHub. Yeah, I should throw it in there. Education.github.com. Go to that link, follow the sites, follow the instructions, and you have a pro account. The benefit of having a pro account is that the primary benefit used to be that you could make private repositories that no one else could see. You could also have as many collaborators as you wanted on the same repository. GitHub recently announced new changes, letting anyone create as many private accounts with repositories as they wanted with as many collaborators in response to COVID. But it's still nice to have because there are a whole lot of other perks that will come in handy as you start using more and more advanced software engineering tools. And the website that Ansh linked actually tells you all the free stuff that you have access to. Doesn't cost you anything. I would recommend go ahead and sign up if you have an EDU account. Second thing that Shreedhar brought up earlier, what's a Git Ignore file? That's a really good question. If you guys remember, if you don't remember, you can always go back and check it out in the video. Or when I created this repository, I had the option to initialize it with a Git Ignore. What a Git Ignore does is it tells Git what kind of files you want it to, what kind of files or folders it should not track at all, no matter what. So, and the reason you want to do this is because, for example, if you're writing something in C, C++, you don't want it to save the object files, the compiled files, because those are going to be platform independent. There's no point in pushing all of that and having the person you're working with get confused about which version, what .o file is actually valid for their computer. So if you're going to do something like that, you would go ahead and do C, whatever language you're doing. If you're doing Python, type in Python. So it would ignore all the PyCache folder, the PyCache folder. If you're doing Java, it would ignore your the Java virtual machine files. Whatever, Git Ignore basically, it's a file that will tell Git what to ignore no matter what. The reason you do this is because usually you just do git add period, which adds all the files in your folder. But if your Git Ignore is telling it to ignore a specific folder, then it will not, then Git won't ever include that folder. So actually, let me go ahead and show you. So let me make a Git Ignore. I really hope this works. Ignore cache stuff. Ignore a folder named cache stuff. So if I create, right? Oh. See, it didn't track the new folder that I made, the cache stuff folder that I made. And that's, so now whatever I add inside this cache stuff is going to be ignored by Git. This is something you'd want to do if you're, especially if you're doing some authentication stuff. So if you have like a unique username and password to access an API, you wouldn't want to share that with all your entire team, because then that's just going to lead to more issues with pricing and stuff. Better that everyone keep all their sensitive information separately in a folder that's also included in your Git Ignore, so Git doesn't deal with that at all. And of course, it's usually used for like ignoring cache folders. You can use the default Git Ignore files for whatever project you're working on, or you can always just Google generic Git Ignore file for Python, and you'll find like a Git Ignore you can just copy paste into yours, and it'll handle it'll handle the issues. Merge conflicts, yes. Merge conflicts are the bane of any, at least I absolutely hate when I get them because they're very annoying to handle. The whole goal if you're using Git and using branches is to make sure that you have as many manageable merge conflicts as possible, but they're definitely unavoidable, especially if you guys are working on a really complicated project, everyone working on the same aspect at the same time. So it's in lieu of just talking about like trying to recreate a Git merge conflict, I'm just going to talk through what exactly is going to happen. A merge conflict is going to happen when two people are working on the same thing at the same time and they make conflicting changes. So let's say I add a function named do stuff. Let's go back here. So if I write something and I do, and then at the same time, someone else adds, and then I push this. And then someone else writes a function or makes a change that actually deletes my do stuff function. That's going to cause merge conflicts, especially if I'm writing code that will also that also edits this. So in the end, when one of us pushes, it's going to lead to a merge conflict. Now, if you guys follow the workflow that I talked about at the very beginning, where everyone makes their own branch, they make a change, they push the branch using whatever the terminal tells you to, following the instructions here, and then make a pull request. What the pull request is going to tell you, let me actually, all right, what the pull request is going to tell you is that it's not able to merge automatically. So let's go ahead. go here. All right, I'm just gonna go ahead and give me a second for, okay, there we go. So right now, this is not going to throw me a merge conflict, but I'm just going to be able to talk through what's going to happen. So right now it says automatically able to merge, which means that there's no merge conflict. So I'll go ahead, usually it would say not able to automatically merge. You'd still go ahead, you'd create your pull request. And then when it shows up, this will be red. So it will say cannot be merged automatically in with the base branch. The way you want to fix that, the way you'd fix that if it shows up, is you would go through, you would find the files that actually conflict. So if you went through, you looked at files changed, you'd be able to see which files actually were codependent on each other and who made the change that actually broke everything and is causing this big mess. You can go through, you can leave changes telling them specifically what they need to do to get rid of the merge conflict. If you're more advanced or you know how to Google, you can also look up how you can clone that pull request specifically into on your own computer, fix everything up yourself, and push that. If you're using VS Code, there are a lot of really nice plugins that you can use. I would recommend use VS Code, very beginner friendly, that you can use to pull specific pull requests and easily handle on your local IDE. And big part of merge, the best advice I have is just Google what's going on, because they're a very common error and they're unavoidable. And you can find tons and tons of sources to help you figure out what's going on. We linked a couple here because merge conflicts are a pretty common thing. So we've given you some advice here, and we've linked a couple cool tutorials here that might be useful for you. Yeah, definitely check out these tutorials. Check out the starter guide. Whew. Does anyone have any questions? Feel free to throw them in the chat. Unmute yourself right now if you want. Otherwise, let's see what else I need to go over. Yeah. Okay, I went over everything I wanted to. If anyone has any questions, anyone was confused by anything, feel free to test. Well, how does GitHub issues play into the workflow? Nice. Okay, let's go here. So the way I'll just show you guys what we're doing here. The reason we use issues is to highlight a part of the code that either A, hasn't been done, or B, needs review. So someone else needs to take a look and maybe make some bug fixes, add a function or something like that. Merge. Okay, yeah, I'll do both of those. So how does GitHub issues play into the workflow? Let's focus on that. So let's say we're looking at this. I think, wow, we're working on this project, hackathon project together. I think, wow, we could really use a section about Bitcoin for some reason. But I'm working on something else right now, or I don't know how to do it. So I'll go ahead, I'll open a new issue called Add a Bitcoin Tutorial. And then whatever more I'm thinking, be it cool and make. All right, I'll go ahead and let's say I think that Arjun is really good at Bitcoin. I know that he can really do a good job here. So I'll go ahead and add Arjun, I'll add Grant. So I'm assigning them, which means that I've identified a problem or a shortcoming in this project. I know that these people have the capability to fix it. So I'm gonna assign this issue to them. Labels, again, this is pretty self-explanatory. It's a new feature because this is something that we don't already have. And projects, we don't have any projects set up in this repository. A lot of this is like for really, really massive projects. So I wouldn't worry about all these little things for hackathons. So add this, submit new issue. And then anyone who checks out our repository can see the issue open here. So that if, let's say even a third person comes up and they're like, if Sridhar walks in, he's like, hey, I can add a Bitcoin tutorial. He can always, if he's logged in, he can ask us to let him claim it and then add it himself. Because it's we're the only collaborators, we can't assign him, but he can always ask to be assigned to it and make that change. Whenever the issue is handled, or let's say they make a pull request, they would merge that in. So they would link a pull request with it, and when you close the issue, it would handle the pull request too. Does that answer your question? That was kind of rambling, Kapil. Sweet. Okay. Alan, can you talk about how to merge existing project into GitHub? Yes. Yes. So again, a large part of this is just following the instructions. GitHub, contrary to what it looks like, is actually very user-friendly. They try to make it as accessible as possible, and they give you as many tutorials as possible. So a large part of this is just following the instructions and Googling whenever, either when you see something on your terminal that you're not familiar with, or you want to do something else that you don't know how to do. So let's say one option is if you have a existing project on your own, like on a different place. So if it's on a different version control system, for example, Bitbucket or Mercurial or something like that. So basically you would just copy paste that URL in, you give it a new name, and you would import it over. Pretty straightforward. And if you already have been using one of those other VCS, you probably already know how to use Git or are familiar enough with the VCS system that I don't need to go into detail. Maybe Alan meant more how to add and something else that is useful is how to add a project that you've already started working on locally, but you want to now like merge it up on Git. So the way you'd create a new repository is Git init. Oh, whoops. And if you look, that was very messy. So I'm going to explain I'm going to go back and do it again, just so I explain what I did to you guys. So let's say I'm back here. I want to create a new Git repository. I do Git init. This is an example. And then now if I look, I have a folder named this is an example. And now this is my, this is a local Git repo. So like we talked about before, there's a difference between Git and GitHub. This Git repo isn't initialized on GitHub. So if I look, and no matter where I look on my Git account, I won't be able to find a repository called this is an example. But it is on Git, which means that my local machine is tracking every change that I make. It's I can commit to my local machine. I can set checkpoints, stuff like that. And the way you'd want to, so the way again, like I said, the command line is going to give you a lot of help while you're setting it up. But the way you want to set up a remote repository is you can create a new repository here. So create a new one. I already showed you guys how to add a new repository. I don't need to clutter it up. But create a new repository, copy the URL, so this URL, and then type it in here. Git remote add, the name of the repository, space, and the URL that you've copied in. And that'll handle the syncing between your local folder and your remote Git. But if you're starting off a project for the first time, the first step should be create a remote Git repository, add everyone as a collaborator, have everyone clone to your terminal, and then begin the process. Oh, one habit that it's a good habit to get into, wow, that sentence, is to always git pull when you start. So I'm gonna go back to my, what git pull does. Git pull is a way of pulling all the changes that have been made by other people on the website to your local server. So if I do git pull, just the way that Git push pushes every change that you've done on your local server to GitHub, Git pull pulls in all the changes that GitHub has done to your local thing. So every time you start working, or every time your teammates tells you that they've made a change, go ahead and type in git pull into your terminal, which will make sure that everyone's working on the same level of completeness as each other. That will again help you guys prevent merge conflicts. One more thing that I wanted to show. What's going on? There we go. Okay, it's loading up, but this is the Git desktop app. And like I said, my computer is pretty trashy right now, so it's gonna take forever. Git PNG, you guys can check it out by yourself if you guys think this will be helpful. When I looked at it, it's more useful for advanced users. This, for me, it would have been pretty intimidating when I checked it out, just because there are way too many words and not enough of an explanation. Feel free to go take a look. But for the most part, you can think about Git as a remote repository that you're pushing and pulling changes from. That's your remote, and this is your local branch. What might be more helpful than just looking at this picture is to look up a couple YouTube tutorials that explain the theory better. Anyway, so yeah, this is the Git desktop app. If you start typing in Git into your terminal and you realize that it throws like a command not found error, it's probably because you don't have Git installed. And the easiest way to do that is just to install the Git desktop app. It's available for Mac, Linux, and Windows. If you do that, it will walk you through how you can install the command line tool and everything. So go ahead and do this. And that, just look up install Git desktop, GitHub desktop, and it'll give you the instructions. And what's nice about this is that if you don't want to use the terminal, you can add you can do most of everything from the desktop app. So I can clone a repository that I have on github.com. So we can look at the demo that we just made here, and I can clone that into this folder. Let me go ahead and do it. And if I make a change, I'll be able to open it here. I'll be able to see the folder here, and I can see whatever changes that I'd make over here, as well as the history. So you can see all the changes that people have made over the course of the hackathon. So it's a pretty nice thing to have, and to actually be able to visualize all the changes. I end up using it sometimes too, but once you get more familiar with Git and GitHub, it's usually faster to just do everything from the terminal, at least in my experience. Your mileage may vary. Any other questions? Like Didi said, this is a very complicated, not very complicated, it can get very complicated, but a very important tool. And it's better just to ask any questions you might have than to deal with it later on. I'm sure some of us, one of us on here can help you out. So feel free to either private message me or just throw it in the chat, unmute yourself and ask it, whatever works for you. Besides that, this is all I had planned for the workshop. We will post the video later on, so you guys can go through it again at your own time if you think that's valuable. Yeah. Sweet. If you guys don't have any questions, that's all we had planned. Feel free to stick around, hang out with us if you want. Otherwise, thank you guys for coming. Project proposals I think we want them in by tomorrow. So go ahead and get that started. Go ahead and get that done. Again, message any of us on Slack if you have any questions about that either. But it's pretty straightforward. It's just to let us know what people are working on and to see how we can assign mentors such that the mentors are best able to help your team.
Thank you, guys.
Wag. Thank you all for coming. We will be here